Hello guys, morning, Rev, Namaste, Dumelang, Goeiemorgen, Akwaba, Ndiepi, Ni Hao. Anyway guys, we have a simple thing today, a simple task today. This is a laptop motherboard. Alright, I want you to understand one thing, how I repair laptops, how I learn all of these things. It's very easy. First of all, whenever I check a board, all right, I check the company make, the manufacturer make. When you see something like DAGDA, something, a code like this is a board number. It means this board has been made by a Quanta. It's a company called Quanta, a manufacturer. They design motherboard for HP, ASA, and for most brands. All right. So the first thing that I do, I check the company and the manufacturer make, whether it's made by Compel or Quanta or ASUS. I check the make, or Intel or all these other big manufacturer that does motherboard. All right, so let's check this one, the structure of this one. Let's check this motherboard. Let's see all the components. I want you to understand everything. First of all, these are RAM slots. These are RAM slots. It has two RAM slots, and it seems like these are DDR4 charging by there. You'll see this space here, spacing here. It's almost equal to both sides, but not equal, almost equal, which means this is DDR, this is DDR4. Yes, if I'm not mistaken, yes, this is DDR4. Let's move on. What else do I check? I check for 3.3 and 5 volts. Right? Judging by this structure here, I have two coils, 1 and 2 coils, and I have a chip in the mix. This is what? This is almost 3.3 and 5 volts. I'm not sure which one is which, but I can tell by structure this is 3.3 and then this is 5 volts. When you see two coils close to one another like this, definitely one of them is 3.3 and the other one is 5 volts. Or otherwise, I was gonna say this is the one, but I can't say this is the one. This is the one. This one here, you can tell definitely that this is going to where. You can see the trackpad is going big pad there. It's going to a graphics chip. This is a graphics chip. You can see the graphics memory. The memory is here around the graphics chip. This is a graphics chip. This is a graphics card section. All right, so they used two power supplies, and I'm telling you here they were using double MOSFET. These are 2-in-1. These are 2-in-1, 2-in-1, and there's a coil. There's an output going to a graphics chip. Okay, let's continue. I'm sure this is a controller. Okay, yes, this is a controller, definitely. This is a controller controlling what? Controlling the GPU. Controlling the GPU and controlling those MOSFETs, double MOSFETs through gates. And it senses what? It checks the GPU as well. Let's move on. What else do you see, guys? This is what? This is a BIOS chip. This is a BIOS chip. This is a BIOS chip. What else can we see? Can see those small components there. The network ports, HDMI ports. This is a charger, a DC inject connector. Yes, if I'm not mistaken. The CPU. And what is this? Maybe this is a RAM power supply or 1.05 volts power supply. I'm not sure, but we are just checking. This is a CPU power supply. You can see CPU power supply, and this is a CPU controller, a chip that controls those MOSFETs. What else? Pretty sure this is for charging or charging a battery. Yes, I think so. Anyway, guys, this is easy. This is very easy. Every time when you have the motherboard, scan it, go through it. You can even see by just seeing the port. You can see where's 3.3. You can see where's the RAM power supply. You can see the GPU. You can see the CPU power supplies, see the MOSFET they use there, what kind of or what type of MOSFET they were using there. Guys, this is so simple. Anyway, let's continue. Right, on the motherboard, we have some fuels. Fuels, they normally look like this. We'll have a letter there. And on the board, gonna be either EF. P stand for power and F stand for fuse. Would be like something like PF power fuse or F alone. I don't know why they said FP here. Maybe they made a mistake. I'm not sure. I think they were trying to say PF power fuse. Yeah, this is a fuse F1503. This is just a fuse. U, they stand for what? For chips. D, they stand for what? For diode. This is a double diode. R, they stand for resistor. This is a multiple diode. This is a diode as well, 0 ohm resistor. I mean, this is a resistor, and this is a resistor, multiple resistor. This is a single resistor there, 0 ohm resistor. I'm not sure about this. Maybe this is the out as well. I think so, but this is fuse, a fuse. And this is a sign for a fuse on the schematic. You see it like this. Fuse. Here we have different type of fuse. Right. Okay, yeah. Okay. No, I think they're right. Maybe fuse power, yeah, something like that. Because here they made correct EF power fuse, and maybe this is fuse power. I'm not sure as well. Okay, there we go. So when you are checking for a fuse, it's easy. You take your multimeter probes, right? Black probe and the red probe, and you put it on the buzzer mode and continuity mode. Listen to me carefully. So you take one probe, you put right there, and on the other side as well, you touch those 2 points, those 2 sides. It should beep. It will have what? A beep. With a beep, make a beep sound and show you that 00000 ohms. There is a continuity of which is directly straight, and that fuse is what? The code fuse. If there is no sound, there is no beep sound, there is no continuity, it means the fuse has been. You have to replace what? You have to replace that fuse. Now let's talk about resistors. Okay, one more thing about resistor that you should know. Resistor, they resist. English is just straightforward. Resistor, they resist. They resist what? Not voltage, but they resist current. Although you can change the voltage, the output voltage using resistors is possible through voltage dividers. More importantly, they mess around with a current, not with a voltage as such, unless if you are using voltage divider. Here you'll learn about the codes. In laptops you won't see this. Even in desktop you won't see this kind of fuse. You only see the SMT fuse. Keep that. Let's keep that. Let's keep that. Let's keep that. Keep that. This is so important. Oh, you know what? Let me just end this. I'm gonna do another video more about the fuse. We'll go through the fuse. Through the resistors. Alright, let me just finish this. Okay, we have resistors in series and resistors in parallel. What is the difference between the resistors in series and resistors in parallel? Here we go. This is a resistors. These are resistors in series, and this I can see this. Okay, this is one thing actually. So resistor in series, there won't be much change. It's just gonna be resistor 1 plus resistor 2, and you'll have a sum of that. For example, they did an example here. If you place 100 ohms resistor in series and another 100 ohms resistor in series, should be your total ohms gonna be 200 ohms because they are in they are in series, meaning they resist in series. But this is what happens when you put them in parallel. When you put them in parallel, this comes a problem. It's gonna be R1 times R2 divided by R1 plus R2. Okay, it's more like half actually. Yeah, you will get like half because current will be divided into two. Hundreds. You will have like 50 of half of one. But the formula is here. This is the formula for calculating the entire thing. You say R1 times R2 divided by R1 plus R2, and then you get your answer. This time total ohms would be half, would be 50, half of one resistor. Yeah. 1.5 kilo ohms. They'll do it like this. They'll put a K in between. Guys, you'll these are the simple stuff. You'll learn about this. You'll learn about this. 80, 0, 105. Okay. I don't wanna go through this. If you don't mind, you can go through this, read the entire thing on your own. I wanna summarize some very important stuff. This is gonna be 2.2. Be 2. Okay. Ohms. 220 ohms. Guys, you will have to learn how to read resistors there. Okay, there we go. This is a voltage divider. This is a voltage divider. A resistors as a reducer voltage, as I mentioned earlier, that even though resistors mess around with a current, but again you can use them to mess around with a voltage by using this called the voltage. And we have some pull up, some pull down resistors. All right. I wanna see. This is a voltage divider. Okay, specifically with a voltage divider, you take two fuse, you put one in the main power rail, and the other one you connect it to ground. Then your voltage output won't be the same as the main power rail. Gonna change. Gonna be change. Here they use 200k kilo ohms. I wish there was a. I wish I was gonna calculate it for you and give you right. This is how you check resistors. Giving you 3.3, of which is fine. Obviously, here it will beep because there is no ohms, 0 ohms. Capacitors. Anyway, let me just stop it right there. I'll do another lesson. Anyway, stay tuned.